Hello everyone, welcome to Petrobarrel. Today's video we will talk about the porosity lab measurements, and we will start by the bulk volume determination or bulk volume measurement. As I said before in the first video and second video, what is the meaning of porosity, the different types of porosity or the different classifications of porosity based on the geological and engineering classifications. Then we will move through what are the different factors affecting the porosity, okay? And in this video we will focus about the measurement in the lab to get the value of porosity. As I said before in the first video, the porosity, it is the ratio between the pore space's volume divided by the bulk volume. So today we will know how to get the value of the bulk volume. As I said before, let's imagine that we have a sponge, and this sponge has a lot of pore spaces or a lot of holes. So the total volume of this sponge refers to the bulk volume of the formation or of the rock sample. Then the matrix volume, this is the volume of the yellow color or the formation itself, okay? And finally, the pore spaces volume, this is the volume of the holes located inside the core sample or the formation of the reservoir. Based on the determination of the bulk volume, we have direct measurement. As I said before, we have core sample or rock sample. So sometimes we have core sample have regular shaped cores. As I said, this is the cylinder shape. So I have radius of this core sample and I have height. So simply to get the value of the bulk volume, I get the volume of this cylinder, which is pi d power 2 divided 4 multiply the length of the core sample. So this is method or the direct measurement applicable for regular shaped cores, and we can calculate the bulk volume from the core dimensions. The second method, which is the volumetric displacement method. This is method simply I submerge or put the rock sample inside this graduated cylinder. So simply the water level increase. Why? Due to displacement of the rock, sum of volume of the water inside this cylinder. So based on this, we will prevent the liquids to enter the pore spaces of the rock by coating with paraffins. But based on this method, we need correction. Why? Because the paraffin, it has volume. So I want to get the accurate volume of the bulk volume of the core sample or the rock formation, okay? So we will make coating, but this method needs to be corrected, okay? The second one, which is pre-saturated of the core sample or the rock of the reservoir with liquid. Why? Because if I have rock and this rock saturated 100% with liquid, so this is helped me a lot to prevent any water came from this cylinder to enter these pore spaces. So this method helped me a lot to prevent the liquids from entering the pore space. The last method we will use instead of water, for example, we use mercury, because mercury, it has a high density, so it is very hard for mercury to enter small pore spaces, okay? So this is based on how to prevent the liquids from entering the pore spaces to ensure we have accurate volume or accurate bulk volume measurement based on the calculations to get the value of porosity with accurate value. The third method, which is Archimedes method. This method simply based on the buoyancy force, at which anybody wholly or partially immersed in a fluid is buoyed up with a force equal to the weight of this fluid, but the weight of the fluid displaced by this body. So this is the Archimedes method, by the way. So the displaced weight equal to the real weight minus the apparent weight. What is the meaning of real weight and apparent weight? Simply, the real weight, this is the weight of this shape in air, at which, for example, I have a stone of 2 kilograms, for example, and this stone, when I put it inside the water and I measure the weight of this rock, okay, or this stone, give me 1.5 kilograms, for example. So this is the difference between real weight and apparent weight, give me the displaced weight. So the displaced weight helped me a lot to get the value of the bulk volume. How? I know from the relation of the density, any density of any fluid equal to the mass divided by volume. So if I put the density here and get the volume here, so this is correct, by the way. So the volume equal to the weight or the mass displaced divided by the density. So here, based on this, to get the value of bulk volume, we get the displaced weight and divided it by the density of the fluid, for example, water, if I used in this graduated cylinder water, okay? And the final step, I subtract from this value the volume of the paraffin when I'm using this correction, when I'm making coating of this core sample or this stone of the formation, okay, by using paraffin. Why I'm using paraffin? As I said before, we use paraffin to ensure not any fluid enter through the pore spaces. So based on the volume of the paraffin I used it for coating, okay, we get the value of the volume of the paraffin. So I subtract from this value the volume of the paraffin to get finally the corrected bulk volume of reservoir rock. Thank you so much. If you have any questions, please tell me in a comment, and I hope this video helpful for you. Thank you so much, and assalamu alaikum wa rahmatullahi wa barakatuh.